Hi everyone, welcome to InterviewPro. Let's solve another LeetCode problem today. I have an easy question here. Find all numbers disappeared in an array. We are given an array of n integers where each element is in the range 1 to n. We are expected to return an array of integers that do not appear in nums. For example, here we have the elements 4, 3, 2, 7, 8, 2, 3, 1. Some of the elements are repeating, and that's the reason some of the elements do not appear in this range. So what are those elements? 5 and 6. Because from 1 to n, we see 1, 2, 3, 4, 7 and 8. Because some of the elements are the duplicates, we see these elements are missing. So we saw similar question, find all duplicates in an array, in our previous video. We are going to follow similar approach here. So the biggest hint here is the range 1 to n. That means for every element in the array, there is a corresponding index. For example, if you take the element 1 and try to find index by subtracting 1, because index always starts with 0 and the elements here are from range 1 to n, whereas indices will be from range 0 to n minus 1. So to find an index corresponding to an element, we have to subtract minus 1. This gives us 0. Going to index 0, we have an element 4. Whenever we go to the element represented by the calculated index, we mark that index as visited. How do we mark it as visited? Just by making it negative. So if there is a 4, it will be minus 4. Because we do not have any negative integers in this array, negative number represents that the element is already visited by some number. We are going to follow this approach for all the elements in the array, and finally, when we loop through the array, we check for the positive elements. If there is a positive element, that means that element is never visited by any of the index. And these are the indices that gives us the element that is missing. Let's debug and see how this approach works. We'll loop through each and every element. We'll start with 4. So the element 4, index would be 4 minus 1, which is 3. Going to index 3, which is 7. This is positive, so we'll mark it as visited. It will become minus 7. We'll go to the next element. The index would be 2. Going to index 2, this is positive, so we'll mark it as negative. Now this is a negative element, but when we calculate an index, always take the absolute value, which gives us 2. 2 minus 1 is 1. Go to index 1, which is 3. This is positive, we'll mark it negative. Going to the next index, this is already negative, so we'll take the absolute value. 7 minus 1 is 6. Going to index 6, 0, 1, 2, 3, 4, 5, 6. This is the index 6. We'll mark it negative. Now advancing to the next element, we have 8. Index will be 7. The element at 7 is 1 and make it negative. Then we have 2. Index will be 1. Going to index 1, this is already negative, so we won't make any change there because we are looking for positive elements. If we keep changing, if we keep multiplying it with minus 1, though irrespective of the sign, then we'll end up with lots of positives which do not give us the proper solution. So if the element is already marked as visited, just leave it, do not update. Now going to the next element, this is minus 3, taking absolute value, it's 3, which gives us index 2. This is already visited, so let's leave it like that. Let's go to another element, which is 1. It gives the index 0. Going to index 0, this is positive, mark it as negative. Now what is the final array? It's minus 4, minus 3, minus 2, minus 7, 8, 2, minus 3, minus 1. We have only two positive elements, 8 and 2. What are the indices? 0, 1, 2, 3, 4, 5, 6, 7. So the indices of these positive elements are 4 and 5. To get the elements, we have to add plus 1 to these indices. This gives us the missing elements. If you look at the original array, what elements are missing? 5 and 6. This is our output. So this is how we got the output, by finding the positive elements, finding the indices of the positive elements, and adding plus 1 will give us the elements. Let's see how to implement this in code. This is the question and I'm coding in C sharp. First, let's declare a list that will contain our result. I list of integer. I'll call it result. New list of integer. We'll loop through each and every element. For each int num in nums, we first calculated the index. So let me calculate index. Index equals, we took the absolute value of the number. So math dot abs of the current element minus 1. This gives us the index. Next, we'll go to that index, nums of index, and multiply it with minus 1. We'll multiply it with minus 1 only when the element is greater than 0. So nums of index is positive, only then we'll mark it negative. If the element is already negative, then we won't make any change. We'll just leave it as it is. At the end, we'll go through the loop again. And I equals 0, I less than nums dot length, I plus plus. Here it will check if the number is positive or not. So nums of I greater than 0. If the element is positive, then we'll add the index plus 1 to our result. So result dot add the element. This represents the missing element. So I plus 1. Finally, we'll return the result. Let's run and see if it works. So this two cases are accepted. Let me submit the solution. This solution is accepted. Coming to time complexity, we are at any point of time we are looping through the array only once. So here we are trying to mark the elements as visited. Then we'll loop through the array again to add the positive elements to the result. So here it's big O of n plus big O of n, which would again result in big O of n. Coming to space complexity, we are just updating the input array. This result output space doesn't come under space complexity. So the space complexity is big O of 1. I hope the concept is clear. If you like the content, please like, share and subscribe to InterviewPro. Thank you.